let's now take our newfound knowledge of the multiplication rule as well as the at least one rule, and let's apply it to our favorite, the two-way table, which is where statistics and probability coincide together. All right, we've looked at this two-way table before. This is active duty military recruits by military service and by race and ethnicity. All right, so we're going to select 3 active duty military personnel recruits at random with replacement. Those are magical words we like to hear, because with replacement means it's independent. And I'm noticing just ahead of time, all the next problems are also with replacement. So these are all going to be independent, which is great because if they're not independent, we can't really do the things from this particular section. So I'll just make a note, right? Independent, right? When we see with replacement, that means independent. All right, so what is the probability that all of them were recruited by the Marines? Magic to our ears, all of them. Okay, so I want the probability of all Marines. And there's 3 recruits here, so I want the probability that I have a Marine for the first one, and then I multiply, because they're independent, for the second one, I want a Marine, and then for the third one, I want a Marine. So they're all Marines. And there's 1, 2, 3, 3 active duty military personnel recruits. All right, well, the probability of a Marine is 31310 divided by the grand total of 163582. So you'll notice there's 3 of these. So this is really the probability of Marine to the 3rd power. And it'll just be easier to do it that way. So we'll do 31310 over 163582 to the 3rd. Because whenever you multiply something by itself, you're raising it to a power. All right, so let's go grab this out of Desmos. I don't know what this is, but I can find it. So 31310 divided by 163582. I'm going to raise that to the 3rd power, and it gets me 0.0070. So 31310 over 163582 raised to the 3rd power. It's the same thing as if you multiplied 31310 times itself. So it's 0.0070. Done. All right, now this one was an all question. This one is none. Now nones are a little bit tricky because you have to find the probability of not getting it and then raise it to the power you're looking for. I talked about it at the bottom of this page. So you want the probability of not being whatever you were looking for to the n power. So we can tell that n is 5, right? So this one had n as 3. This one has n as 5. And just to preemptively get this done, this one has n as 7. We can see. Okay, so let's think about this. I need to find the probability of not black. So the probability of black, let's start there. And this is for one recruit. We're going to do this ahead of time. I will say none works very much like the at least one rule. None is a bit tricky. So the probability of black is, let's see, 28401 divided by 163582. So the probability of not black is 1 minus that. Which would be, okay, so if I take the 163,582 recruits, so I'm going to take 163582 and I'm subtract away 28,401 black recruits. That leaves me 135,181. So 135,181 non-black recruits. You could also get a decimal, right? So you could also say, hey, tell me what that is in a fraction, but it doesn't matter. It's not particularly required. Okay, now we did all of that ahead of time. This is kind of preamble work. So now I want the probability that none of the 5 recruits are black. I made recruits are one word, which doesn't make any sense. There you go. None. Okay, so that means I want the probability of not black raised to the 5th power, right? Because my index was 5. I'm going to do this for 5 recruits. But I know what the probability of not black is. I just found it. So I'm going to take the 135,181 over 163,582. I'm going to plug that into there, right? It's very much like at least ones. Nones and at least ones are very, very close to each other. So I will just grab Desmos and say to it, hey Desmos, what's 135,181 divided by 163,582 raised to the 5th power? And it's 0.3854. I don't know how many decimal places we wanted here. So I'll go 3854. Okay. So this is work that you have to do for 1 recruit, and over here is for 5 recruits. That's the difference between the two. So this side is 1 recruit. It's kind of preamble work. You've got to find the probability of black, then you find the probability of not black. Then you go figure out the probability of not black to the 5th power. And it's very close to what we're about to do, which is the last one, which is an at least 1 problem. So at least 1 basically does everything we just did, but at the end we take that number away from 1. So instead of just the probability to the 5th power, we'll take 1 minus that. But other than that, it's basically the same, right? So, and I can tell it's rule number 5, but I want AIAN, which is American Indian Alaskan Native. All right, so for 1 recruit, you always have to do this for at least ones and nones. They both have the same kind of setup. You've got to find the probability of AIAN. Okay, AIAN is 1280 over 163,582. Okay, so the probability of not AIAN is 1 minus that, which I've got a little bit of room down here. I'll find it. So let's get rid of this. All right, so out of the 163,582 recruits, I want all the ones that are not Alaskan Native or American Indian Alaskan Native. So 1280 away from that gives me 162,302. All right, I wrote it down. So there's the 162,302. All right, so now let's go deal with, and this was all for 1 recruit over here, right? So 1 recruit over on this side. Let's go deal with the 7 recruits over on this side. Okay, for 7 recruits, let's look and see what we've got going on. I want the probability of at least 1 AIAN. Okay, that's 1 take away the probability of not AIAN to the 7th power. That's the rule, right? You find the probability of not getting what you wanted to the 7th power, which is 1 take away that number that we just found, right? We found the probability of not AIAN. It's 162,302 over 163,582. And we raise it to the 7th power. And we are totally making Desmos do this. We are not typing any of this in. All right, so 1 takeaway, parentheses, 162,302 divided by 163,582, close parentheses. I'm using my arrow keys to get me out of there because I don't want to be in the denominator anymore. So I close my parentheses and then I raise it to the power by doing Shift 6. So there's a little caret button, a little hat, and then 7. And it's 0.0535. And hopefully you can now see how close these two problems are. That's what makes them really tricky. None does this one recruit business. Probability of black, probability of not black, then go take it to a power. This one does the same thing. Probability of AIAN, probability of not AIAN, but for single recruit. Then you go raise it to a power, but you take it away from 1 because you want at least 1. So the at least 1 rule works that way. So it just takes the probability of none and kicks it up one more notch. And I will say, don't avoid the work. So many students try to just jump right into this stuff over here. And when they do, they end up in trouble. They can't do it. They'll put the wrong numbers in, they'll put the wrong denominators in, they'll just do it wrong. So take the steps to figure out this bit over here. It's just a few minutes or a few seconds, really. And once you get that bit down, then go plug it into the formula and you're perfect. Trying to jump right into the formula right off the bat is a recipe for disaster. Don't be lazy and do the extra work. It'll be worth your while because then you'll get the credit for the problem.